Hello and welcome to Week 12, Part 4 of EGM310, Archaeology Applications. In this lesson, we will learn about how we can use remote sensing to locate and study archaeological sites. At the beginning of Week 1, I showed this example from a site in southern Mexico called Aguada Phoenix. It was built between 1800 BC and abandoned around 750 BC. This study is an example of using LiDAR to map ruins that are obscured by vegetation. This region is covered in thick forest cover, which makes most mapping attempts much more difficult. While full study of sites like this still requires fieldwork, remote sensing can help narrow down the search for these sites, showing us where to start digging. One of the ways that remote sensing can help us discover lost sites is by enabling us to see surface features in remote areas. These can take the form of visible ruins, mounds indicating burial sites or covered ruins, rock piles indicating human activity, or surface markings that are difficult to discern from ground level. One of the more famous examples of this is the rediscovery of the Nazca lines or markings in Peru. In the early 20th century, airplane pilots noticed these markings, created sometime between 500 BCE and 500 CE, which depict geometric patterns and shapes, as well as designs of animals and plants. Many of the markings are difficult to see from the ground, but from the air, the designs and patterns are clearly visible. Remote sensing can also help us find features that have been buried or are otherwise obscured by vegetation. These can be revealed due to subtle differences in crop growth, soil moisture or chemistry, surface temperature, or topography. One example shown here is the ancient city of Tanis, once the capital of Egypt. In the image shown here, the ancient city occupied much of this barren hill. While a number of ruins have been found and explored, the use of remote sensing has helped to expand and map much of the ancient city, even though most of the features are not visible from the ground surface. Small-scale differences in near-infrared reflectance show the outlines of foundations of ancient buildings and streets. There are links at the end of this lesson that you can follow to learn a lot more about these discoveries. Another example is this one, showing the foundation of a Roman villa beneath a grain field in northern France. Directly above the foundation of the villa, the soil is thinner and the root systems of crops are unable to grow as deep as they are in the rest of the field. As a result, plants directly over the buried foundation are more easily distressed, or they are unable to grow to the same heights. These differences, difficult to see from the ground, are clear when seen from a different perspective. A LiDAR pulse or signal will see different parts of vegetation cover. The signal returned will have peaks corresponding to the thickest parts of the vegetation cover and to the ground, as well as to intermediate parts of the cover. Using this, we can remove the vegetation from elevation models, leaving only the elevation of the ground, also known as a digital terrain model. As we've discussed, this can reveal objects that are obscured or covered by vegetation, such as the ruins at Aguada Phoenix and other Maya cities in Central America. Even where vegetation cover is more sparse, however, subtle differences in topography revealed by high-resolution LiDAR scans can reveal the presence of human structures, such as the roads or field boundaries dating to colonial New England shown here. As you covered in the underwater remote sensing part of this module, currents can create scour pits around partially buried shipwrecks and other underwater structures. During slack tides, these scour pits can fill with loose sediments. These sediments can then become resuspended during flood and ebb tides, creating sediment plumes. In shallow enough water, these sediment plumes can be seen in satellite images, enabling us to map shipwreck locations. An example of this is shown here off the coast of Belgium. If we zoom in on this area, we can see the sediment plumes created by two ships that were sunk during the Second World War. These locations were previously known, but by applying this technique to areas where shipwreck locations are less well known, we can potentially find other shipwrecks in relatively shallow waters. In this lesson, we have discussed how remote sensing can help us to identify or discover archaeological sites, both ancient and modern. We can map surface features using the same elements of visual interpretation that we've discussed previously, using shape, texture, patterns, shadows, and other features to help us identify archaeological sites. Subsurface features can be detected in a number of ways, including through the use of multispectral imagery to enhance subtle differences in plant health or soil moisture and chemistry. We can also use thermal bands, as underground structures and cavities can have a different thermal signature from the surrounding area. Finally, we can use LiDAR and high-resolution digital elevation and terrain models to see through vegetation and map topographic features. And we're not necessarily limited to terrestrial sites. We can use remote sensing to locate certain underwater features as well. I've included a few different links to a project led by Sarah Parkak. The first is a short TED Talk that introduces some of the same concepts that we've discussed here, how we can map and identify archaeological sites using remote sensing. The second link is to a project called Global Explorer, led by Sarah Parkak, where you can actually apply the skills that we've discussed in this module to help map sites around the world and learn more about remote sensing and archaeology. Finally, I've linked to a few articles which go into a bit more detail about the different things that we've discussed here. That's all for this lesson. I hope you found it interesting, and if you have any questions, please don't hesitate to email me or post in the discussion forum on Blackboard. Bye!